In this section, we'll talk about some intermediate level Scala tricks that you can use when you're developing your software. First, we're going to talk about trait stacking and the abstract override keyword. And then we're going to talk about a few function declaration tricks that you can use. So let's start with trait stacking and abstract override. We'll talk about constructing traits that can layer functionality, using abstract override as a way to declare stacking points, and finally we'll talk about some of the dangers of trait stacking briefly. Let's get started. Let's say that I'm trying to build animals a little differently than we had in previous sections. Let's say that I want to create a trait animal, and it has one live one day method, and that method is a sequence of strings that describe the actions that an animal can take. And let's say that all animals are expected to walk, for example. And let's say that I wanted to declare a wolf, and a wolf can walk, but it can also eat other animals, and it can attack a farm. So maybe I declare a wolf, class wolf, it extends animal, and I'd override live one day, and I would declare that the wolf can walk. Well, we already know that the wolf can walk, so we'll pull that from animal and say super.live one day, and then add to it the ability to attack a farm, and add to that the ability to eat an animal, or the task of eating an animal. So we've defined this wolf, and if we ask a new wolf to live one day, we'll get walk, attack farm, and we'll get live one, and we'll get eat animal. So we've got these three actions. But let's say now that I wanted to also declare a fox, and the fox also can do these same two things, attack a farm and eat an animal. So I could declare a fox that does these same things. This one can also attack the hen house specifically. And if I ran wolf.live one day, I would get this. If I ran fox.live one day, I would get the same things plus attack hen house. But there's no good way for me to, I can't say that a fox is a wolf. So I can't borrow the things that a wolf does to declare what the things that a fox does are. What I'd like to do is be able to stack some traits together to allow me to essentially build up what an animal can and can't do based on those traits. So what we can do is we've got this trait animal, and we can declare a trait attacking animal. And it's got live one day as a seek string, and we're going to go ahead and say that it extends animal. So all attacking animals are animals. And it's going to say super.live one day plus it attacks a farm. Now, when we do that, you see that we need an override modifier. Even though this is a trait, if we override something in a parent trait, we still need to declare that this overrides it. So, all right, we go ahead and say override. And then we also want to declare a carnivore animal. And the carnivore animal is an animal that eats other animals. And I want to declare a hen attacker animal. And the hen attacker animal is one that does the same thing as a regular animal, but it also attacks the hen house. So now I've got these. I can declare a wolf a little differently. I can say that it extends animal with attacking animal and with carnivore animal. And now if I create a new wolf and I ask it to live one day, I get walk, attack farm, eat animal. Now an interesting thing about this is I can reorder that it does these things in by saying it's an animal with carnivore animal with attacking animal. So I change the order of the mix-ins, and now if I instantiate it, the order of this goes differently. Because the first thing that we call is wolf, and then we go left to right, or rather right to left. We call attacking animals live one day, and that calls the super live one day, so we go up to carnivore animal. We call its live one day, and it calls super.live one day, so we go to animal. Animal returns a sequence of walk, then carnivore animal adds eat animal, and then attacking animal adds attack farm, and that's how we build up this order. When we had it stacked in the other order, we went from carnivore animal to attacking animal to animal, and we got seek walk, then attacking animal mixed in attack farm, and then carnivore animal mixed in eat animal. Now, in addition to this, we can also declare a fox who extends animal, with attacking animal, with carnivore animal, with hen attacker animal. And now if we do a new fox.live one day, then we get all 4 of those actions. Now the thing about this particular setup is if we wanted to, for example, have a crow who can eat an animal but cannot walk, cannot attack a farm, and is not going to attack a hen house, if I wanted to declare a crow, I would say, okay, crow extends animal, and I would say override def live one day, seek string equals super.live one day, fly. Now if we do this and we do new crow.live one day, we've got walk and fly, which for our purposes, a crow doesn't really walk around. I mean, it does, but not really. So okay, so that's all right. We'll just change this crow to just return a sequence with a single element in it that's fly. All right, so now if we declare a new crow, live one day, we just fly. Now let's say that we want to add a raven, though. We want to add a raven, then all of a sudden the raven's going to look the same way. It's going to have that fly declared. But if we wanted to move that into a trait, flying animal, and it extends animal, we'd want to structure it the same way so that we could mix flying animal with attacking animal, or flying animal with carnivore animal. And there's no good way to do that right now without also pulling in that walk on animal. So I would say super.live one day plus sequence fly and plus just the fly. And the end result would be if I mix that into a class raven extends animal with flying animal, then creating a new raven and asking it to live one day gives us walking and flying. So what I'd like is to say that animals don't have to walk. Animals by default do nothing. And then anyone else can come in and stack additional functionality on top of it. They start with a blank slate, basically. So the way that I might do that is to say that the trait animal defines live one day, and that is a sequence of string, but we don't actually implement it. Now, if we do that and we go create our flying animal again, we get an error. And that's because you see here, method live one day in trait animal is accessed from super. So this really long-winded error message basically says, the way that this is structured, I don't know that there will be someone implementing live one day above the level where flying animal is. All I know is that live one day exists. So I can't call super.live one day necessarily, because I don't know when someone is going to put a flying animal before this and when they aren't. So the way that this works is we declare this to be an abstract override. And that lets us define it. And all it says is we know at some point there is a guaranteed person who's going to provide a super implementation of live one day. So to handle this, let's go ahead and change trait carnivore animal as well. And we'll make this an abstract override as well. And let's try and declare raven as a mix of flying animal and carnivore animal. So class raven extends animal with flying animal with carnivore animal. Let's see what happens. This time we're told raven needs to be a mixin because method live one day is marked abstract and overrides an incomplete superclass. So what that means is there's nobody who furnishes a guaranteed definition of live one day. So what we're missing is the core sort of starting point. That is the completely stable version that doesn't call super at all. And what we can do is define an empty animal who extends animal, does an override def of live one day, and returns always an empty seek. Once we do that, raven can extend animal with empty animal with flying animal with carnivore animal. Now we can declare the raven, and what happens is we start with carnivore animal. Carnivore animal says super.live one day. Super is flying animal. Flying animal says super.live one day. Super is empty animal. Empty animal says empty seek. So we take the empty seek, append fly, then we take the seek with fly, append eat animal, and we end up with this seek that has fly and eat animal in it. The very critical thing here to keep in mind is that when we work with abstract override, we still need to provide some sort of base implementation that is the place where all the supercalls will eventually terminate. In this case, we called it empty animal. You can kind of call that whatever you want. In a lot of cases, you don't need to do this. We could have declared animal, for example, to just return an empty seek over here. It all depends on how you're modeling your problem domain. The very nice thing about doing it like this, though, is that animal is just an interface. It has 0 implementation details. And you choose your implementation details when you actually declare your class by picking what your base parent trait is going to be, essentially. Now, the only danger with this is there are cases where you can start conflating your dependencies. So we could have live one day. Here we're just returning tasks. But we could introduce a trait very easily that during live one day starts doing other stuff. In addition to just returning these plain strings, it starts modifying some state or doing whatever else. And that can be very hard to see when you're mixing a bunch of traits in together. It can be very hard to know what each of those traits is doing unless the functionality that they're stacking is very simple. So you want to be very careful when you create these stackable hierarchies to make sure that each stack in the hierarchy, each layer, is doing like some version, some variation of a single thing, and that they're all laser focused on achieving that thing together, and that they're not kind of stacking unrelated functionality and eliminating separation of concerns for the sake of being able to easily construct this class. So that's the warning I'll leave you with.